The SLK multi-matrix is a polycentric microprocessor knee designed to replicate the natural flexion of the human knee. Unlike other monocentric designs, the SLK shortens in swing phase to provide high toe ground clearance and a reduced chance of tripping. The amputee is provided a safe and efficient low-energy gait. Intelligent self-learning programming continuously adjusts to the amputee as their gait progresses. The SLK multi-matrix is available in two models, the transfemoral model and the KD model, which is specifically designed for the biomechanical and cosmetic needs of knee disarticulation amputees. High-strength carbon fiber construction make the multi-matrix and multi-matrix KD the lightest weight microprocessor knees available, yet they are each capable of supporting a body weight of up to 275 pounds. Recommended bench alignment. With a 5 mm heel, set the anterior superior axis, or knee center, 5 to 10 mm posterior to TKA. Recommended static alignment. With a 10 mm heel, the knee center is recommended to be set at a maximum of 15 mm posterior to TKA. The microprocessor of the SLK multi-matrix is pre-installed with 5 self-learning programs. Each self-learning program is known as a matrix. Each matrix is configured to optimize swing and stance phase dampening for amputees with different needs and capabilities. Use this 3-dimensional matrix selection chart included with your knee to choose the matrix that matches your patient's profile. A patient profile consists of their weight, activity level, and femoral length. As an example, our patient today currently weighs 175 pounds, is of moderate to high activity, and is considered a long residual femur at 10 1/2 inches. Based on this data, it will be best to begin dynamic alignment in Matrix 4. The next step is to enter the selected matrix using the wireless remote. Now that the best matrix has been chosen, we can enter the matrix using the wireless remote. First, press any button on the remote to wake it from sleep mode. If the blue indicator light in the bottom right-hand corner of the remote is blinking, the remote is searching for a Bluetooth connection with the knee. The knee is either out of the 30-meter range of the remote, or the knee is itself in sleep mode. Flex the knee several times to ensure it is not in sleep mode. Verify the appearance of a green light on the knee's posterior, indicating the knee is on. The knee and remote have paired when the Bluetooth indicator light on the remote is solid blue. Press and hold the auto manual button until the remote beeps twice. Verify that a blinking dot has appeared next to the number in the window of the remote. Using the up-down arrows, scroll to your desired matrix, 1 through 5. To enter your chosen matrix, press and hold the auto manual button once again until the remote beeps twice. The beeps confirm that the matrix has been successfully entered. The top window of the remote will now show 0. The SLK multi-matrix will now self-adjust extension and flexion dampening according to the parameters defined by your chosen matrix. The Custom-ICR setting maximizes stability and efficiency by customizing the knee's polycentric geometry to the amputee's individual femoral length and muscle strength. Without altering TKA by sliding the socket, stability can be maximized by simply adjusting the location of the instantaneous center of rotation, or ICR. The stability created by adjusting the ICR to its maximum posterior location is equivalent to sliding a single-axis knee posterior approximately 1 inch. An ICR position that is more posterior and also more superior translates to increased stability and efficiency, as is required by an amputee with a shorter femoral length and/or poor muscle strength. An amputee with a longer femoral length and/or normal muscle strength requires less inherent stability. In this case, positioning the ICR closer to TKA will prevent the knee from hanging up in swing phase due to excessive stability. Adjust the Custom-ICR setting to femoral length during bench or static alignment, then fine-tune the setting to muscle strength during dynamic alignment. To make the adjustment, locate both the 5 mm adjustment screw and the 2 mm set screw on the knee's posterior side. This chart will guide you in making the recommended adjustment. The Custom-ICR setting is factory set to a patient with an 8-inch femur. Turn the screw 1/4 turn clockwise for every inch of femur shorter than 8, or 1/4 turn counterclockwise for every inch of femur longer than 8. Pause the video to find your patient's femoral length and make the recommended adjustment to the Custom-ICR setting. As an example, our amputee has a femoral length of 10 1/2 inches, which means we'll make a 1/2 turn plus a 1/8 turn in the counterclockwise direction. The Custom-ICR setting has now been optimized for the patient's femoral length. You may want to fine-tune the Custom-ICR setting to the amputee's muscle strength during dynamic alignment. If the amputee's muscle strength is poor and requires more stability, turn clockwise 1/4 turn at a time until the amputee is sufficiently stable through stance phase. If the knee is hanging up in swing phase, the ICR position is too stable given the amputee's muscle strength. Make 1/4 turns at a time in the counterclockwise direction until the knee releases into swing phase smoothly. Once the Custom-ICR setting has been adjusted, the stance flexion setting can be adjusted. The SLK multi-matrix provides up to 15 degrees of stance flexion cushion at heel strike. To make your adjustment, locate the 2 flathead screws on the knee's anterior side. The stance flexion adjustments are clockwise for more resistance and/or a decrease in maximum stance flexion angle, and counterclockwise for less resistance and/or an increase in the maximum stance flexion angle. The purpose of the red tabs is to ensure there is sufficient pressure on the middle posterior axis for the stance flexion feature to function properly. To provide maximum stance flexion angle, loosen each screw one at a time until the red tabs pull out easily. Then screw back in 3/4 of a turn. Make sure the screws have been adjusted equally by verifying each screw slit faces in the same direction and the same number of threads are showing. During dynamic alignment, smooth the stance flexion moment by adjusting resistance to reflect the patient's weight and activity level. Always be sure to remove the red tabs before dynamic alignment. Before the patient takes their first steps in the SLK multi-matrix, it is recommended that the patient be coached on the extremely low energy requirement of the knee's design. Very little energy expenditure is required from the user to initiate gait, conserving the user's energy throughout the day. Be sure the first steps are taken slowly so the amputee can feel the ease of walking with this lightweight microprocessor. To adjust extension assist, first remove the pylon using a 5mm Allen wrench. Loosen the 12mm nut holding the extension assist screw in place. Using a 5mm Allen wrench, turn the extension assist screw. The recommended adjustment is 1/2 turn at a time, counterclockwise to decrease extension assist, or clockwise to increase extension assist. Tighten the pylon clamp to 132 inch-pounds or 15 Newton-meters. If knee flexion is too fast, or the knee is still experiencing terminal impact, it may be necessary to trim the extension assist spring. To access the spring, remove the prosthesis. Using a 5mm Allen wrench, loosen the pylon clamp, remove the pylon, and completely remove the pylon clamp screw. Flex the knee to maximum flexion. Using a 12mm wrench covered by a thin cloth to prevent scratches, turn the nut clockwise. The extension assist housing will spin and extend out of the bottom of the knee. You can now remove it from the knee frame. Using a grinder or a pair of cutters, remove 2 coils from the spring. grind the edge to smooth it. Place the cut end of the spring distally in the extension assist housing. You can now return the extension assist housing to the knee, making sure the groove of the pylon clamp screw is positioned properly. In the case of excessive heel rise, or if the knee appears loose, increase dampening by entering the next matrix up. On the remote, hold the auto manual button until it beeps twice. Scroll to your newly desired matrix, then hold the auto manual button again until it beeps twice. If the patient's gait appears stiff, decrease dampening by entering the next matrix down. At this point, all adjustments have been made. The SLK multi-matrix will instantly adjust to changes in the amputee's cadence. Remember to affix the maximum flexion bumper by hand tightening with an 8mm socket, and verify that the pylon clamp is torqued to 132 inch-pounds or 15 Newton-meters.